Hi, and welcome to the third and final video for section 10.1. This is solving systems of linear equations with two variables. In video 1, we looked at the substitution method. Video 2, we looked at elimination method. In both of those cases, we got x is equal to some value, y is equal to some value. This video, we're going to look at special cases, specifically if there's no solution, or on the other end of the spectrum, there's an infinite number of solutions. So let's see what those would look like. So first, let's say I want to solve 8x minus 2y is equal to 5, or negative 12x plus 3y is equal to 7. So we can see in this case, substitution probably not the best option for us, right? Because if we tried to solve for any variable, we're going to get a bunch of fractions, and let's try to avoid fractions if we can. So I'm going to go with the elimination method. You can choose whichever one you want. So let's say we try to get rid of the x term. So what would be the common factor here? Well, if we go to 24, we'd have to multiply this row by 3. This one's already negative, so we would just have to multiply this row by 2. So if we do that, what do we get? So if I multiply this row by 3, the first row, I get 24x minus 6y equals 15. In this row, I'm just going to multiply it by 2. So if you remember in video 2, I had to multiply one of the rows by a negative value to change the signs. This one I don't, because one's already positive, one's already negative. So if I multiplied this by negative 2, it's going to make this positive 24, and now they don't cancel out. So I'm just multiplying by 2. So I get what? Negative 24x, 2 times 3y is plus 6y, and 2 times 7 is 14. So now I'm going to add down, whoops, this should be minus, negative 12 times 2, negative 24. So if I add down, what do I get? 24x minus 24x is 0. But what happens here? Negative 6y plus 6y is also 0. So that means I end up with 0 on the left-hand side. What about on the right? 15 plus 14 is 29. So by elimination method, I've now gotten an equation of 0 equals 29. Well, that's false. 0 does not equal 29. So this means what? If I am working a problem like this and I get 0 equals a non-zero number, a false statement, what this means is there are no solutions. There is no value for x and no value for y that if I plug it in to these equations is going to give me an answer for both equations. I could pick a value for x and y that gives me 5, but it's not going to work for the second equation. And that's what this is telling me, is that because both of my terms eliminated out to give me 0, but I didn't have 0 on the right-hand side, there's no solutions. There's no value of x and no value of y that I can pick that will make this system of equations true. So that's one option, the no solutions version, where we get 0 is equal to some non-zero number. The second possibility is the other end of the spectrum, as I had said, which is an infinite number of solutions. So let's say I have 3y. I'm going to switch pens here, kind of running out of ink, I think. Want to make sure you guys can see it. So let's say I have 3x minus 6y equals 12, and 4x minus 8y equals 16. So in this case, I'm just going to multiply, so I'm going to try to get rid of the x terms. So I'm going to go to 12. 4 times 3 is 12. So if the top one, if I multiply that by 4, what do I get? I get 12x minus 24y equals 48. And in the bottom row, the bottom equation, what do I have to multiply? Well, now I have to multiply by negative 3. So that when I multiply 4x times negative 3, it gives me minus 12x, so that my x terms cancel out. And then negative 8y times negative 3 is plus 24y. And 16 times negative 3 is negative 48. So now you can probably see what's happening here. 12x minus 12x is 0. Negative 24y plus 24y is 0. 48 minus 48 is 0. So with the no solutions possibility, we had what? 0 is equal to something, some non-zero number. In this case, when we get 0 equals 0, it means we have an infinite number of solutions. However, just because it's infinite doesn't mean every single number works. So there's a very specific way we have to identify what the solutions are. So what we're going to do if we encounter this kind of scenario is I'm going to say let x equal x. It's like, okay, that's funny. Yeah, I know. Bear with me here for a minute. So when I do that, what I want to do is then solve one of these equations for y, so that I get y equals some value, some equation in terms of x. So if I pick this first one, and I have 3x minus 6y is equal to 12, if I bring the 3x over, I get negative 6y is equal to negative 3x plus 12. So divide everything by negative 6. I get y is equal to, the negatives cancel out, so I get 3 over 6, which is 1/2. And 12 divided by negative 6 is negative 2. So we're going to say x is equal to x, y is equal to 1/2 x minus 2. So my solution then for this, I would write it as the following ordered pair. X, and then whatever y is in terms of x. So 1/2 x minus 2. So as I said, every value won't work. I can't say, well, let x be 0, y is 0. Well, no, that's not going to work here. But this specific set of ordered pairs will work no matter what I choose for x. So if x is 0, then that means what? Y, so this is my x value. This is my y value. So if x is 0, well, y is equal to what? 1/2 times 0 is 0, minus 2 is negative 2. So 0, negative 2 is an answer. Well, what if x is equal to 2? If x is 2, 1/2 times 2 is 1. 1 minus 2 is negative 1. So 2, negative 1 is also an answer. And as I keep doing this, what am I creating here? I'm creating a line, right? So I have 0, negative 2. And I have 2, negative 1. So all of the points on this line are all solutions to this system. So it's infinite because the line keeps going, but it's not every single number in the world because negative 1, positive 1 is not on the line, so it's not a solution. But this line represents the entire solution set for this system, which can be written as x and then 1/2 x minus 2. So that idea is a little bit trickier, this infinite solutions, but if you get something like this, just let x be itself in our solution set, solve one of the equations for y, and whatever you get for that goes in for our y answer, and then any combination where we pick some value for x and solve for the y value is going to give us an answer, which is that line. So come on back and we will look at section 10.8. Going to make a little jump here, but we're going to jump to 10.8 before we move on to 10.2.